Assalamualaikum and hi. My name is HAIQAL bin Muhammad DINO. My student ID is 2022877722 and I am from class A4 AS120119. And in this video, will be talking about chapter 2, subtopic 2.1, wavelength and frequency. First and foremost, let's talk about frequency. What is frequency? Well, frequency is the number of waves created per second, and it can also represent the number of waves passing through a point per second. And as you can see, what I'm showing right now are two waves passing through a point. Here's the first one, and here's the second one. For mathematical calculation, the formula for frequency is 1/time in seconds with the unit hertz with the symbol Hz. Next up, I will be talking about wavelength. Wavelength is the distance between two consecutive points between two waves. For example, on the screen you can see two types of waves passing through a point per second, one with high frequency and another one with low frequency. The one with high frequency have shorter wavelength, while the other one with low frequency have a longer wavelength. In mathematical calculations, the unit for wavelength is nanometer. Moving on, I will now be talking about electromagnetic spectrum. What is electromagnetic spectrum? Electromagnetic spectrum is an arrangement of electromagnetic radiations arranged in order of increasing frequency or decreasing wavelength. The electromagnetic radiations that make up the electromagnetic spectrum consist of radio wave, microwave, infrared, visible light, ultraviolet, X-ray, and finally gamma ray. Going from radio wave to gamma ray, the arrangement of the electromagnetic radiations are in order of increasing frequency, with radio wave having the lowest frequency and gamma ray having the highest one. Meanwhile, going from gamma ray to radio wave, the arrangement of the electromagnetic radiations are in order of increasing wavelength, with gamma ray having the shortest wavelength and radio wave having the longest one. Next up, I will be talking about waves. Generally, there are two types of wave that we should know, which are transverse wave and longitudinal wave, which is only a sound wave. What you are seeing on the screen right now is a transverse wave. Transverse waves are made up of crests and throws. The distance between the top of a crest or a bottom of the throw to a center line is called the amplitude. Amplitude is the maximum displacement of vibrating particles from its equilibrium position. The wavelength of a transverse wave is the distance between two consecutive crests or throws. What you are seeing right now is a longitudinal wave, which consists of areas that are stretched out and compressed. The area that is stretched out is called rarefaction, while the areas that is compressed is called compression. The wavelength in longitudinal wave is the distance between two consecutive rarefactions or compressions. Next up, I will be talking about mathematical relations in this subtopic. What you are seeing on the screen right now is a set of formulas used in calculations involving wavelength and frequency. Each quantity is measured in different units. Speed is measured in meters per second, frequency is measured in hertz, and wavelength is measured in meters. For calculating speed of waves, the speed will always be constant, which is 3 times 10 to the power of 8 meters per second. For example, if you want to find the speed of wave, then you should time frequency with wavelength. If you want to find frequency, then you should use the formula speed over wavelength. While if you want to find wavelength, then you should use the formula speed over frequency. That's it for the end of the video. I hope the piece of information I've presented in this video is beneficial to you. Thanks for watching, and I'll see you again next time.